Hello friends, how are you? I am Dr. Rajesh, working as assistant professor in GMN College. Uh, I am back with my second video, and as I promised in the first video, the topic of the second video is differential equation of central orbit in polar form. So in this video we will deriving the differential equation of central orbit in polar form, and this is an important question in BSc final year, and hardly there is any time when this question doesn't appear in the examination. So we will be discussing the differential equation of central orbit. Let us consider a particle P describing as central orbital motion about point O. O is a fixed point, and the force per unit mass is always directing towards the center, and this particle, as it is attracted towards the center, therefore it has only radial acceleration, and it will also be having the transverse acceleration. That component will later be 0, and let the coordinates of the particle are r and theta at any time t. So let us write these things. Let p r theta be any particle describing central orbital motion F is the force per unit mass of the body acting towards center. Acceleration will be having two components. One is radial component, radial acceleration, and we know that radial acceleration is always equal to r theta square, where dot represents derivative with respect to time, and at is equal to transverse acceleration, and this thing is equal to dy dt of r square theta t and 1 by r. These two are, this is the radial acceleration, that is the acceleration acting towards the along the radius, and this is the acceleration acting perpendicular to the radius. These two expressions I will discuss separately in my next lecture, where I will be deriving the formulae for these two accelerations, that is radial acceleration and transverse acceleration. For the time being, we will be using these formulae as such in this particular article. Okay, next, we know that body is under the central force only. So in that case, we may assume that the transverse force acting on the body is 0, and the only force that is acting upon the body is radial force. So here we will write since the central force is the only force acting upon the body, therefore transverse force is equal to 0, and we know that force is equal to mass into transverse acceleration equal to 0. This implies that mass, and I am going to put the value of at from above equation, and that equation is this one. Okay, so I'm going to put the value. This will be 1 by r dy dt r square theta equal to 0. This implies that this cannot be 0, this cannot be 0. This implies that d by theta d by dt r square theta equal to 0. Now we will be integrating both sides. We will get r square theta dot is equal to constant. It will be some constant, say h, say. This implies that r square theta dot is equal to h, and say this equation is equation number 1. Now we will be writing the equation of motion. Since the body is under the action of only radial force, therefore Fr is equal to radial force, and which is further equal to m dot ar. So this will be the force acting upon the body, which will be further equal to m dot r dot minus r theta dot square. Also we know that the total force acting upon the body is acting upon the body is mass into force per unit mass. This is F total is equal to m F. From equation number 2 and equation number 3, this will be the radial force, so this will be all along OP, and this is the central force, so this will be along PO. From 2 and 3, since their directions are OP and PO, so if we compare, then in that case I'll have to write m r dot minus r theta square is equal to minus mf. This will cancel out. This implies that r double dot minus r theta square is equal to minus f, and this will be equation number 4. Now we need to find the value of r double dot theta dot square. From equation number 1, we know r square theta dot is equal to h. This implies that theta dot is equal to h by r square. So we can determine the value of theta dot from here, and you may name it as equation number 5. Let us assume that r is equal to 1 by u, where u is function of theta. Because as r was function of theta, therefore u which is reciprocal of r will be function of theta only. Differentiating both sides with respect to t, dr by dt. Here composition will be used because u is function of theta, so therefore firstly we will be differentiating it with respect to theta, and then theta will be differentiating with respect to t. So this is how we will use the composition. This will be further equal to minus 1 by u square du by d theta into d theta by dt. Using equation number 5, and say this is equation number 6, u square du d theta. Using equation 5, this is h by r square minus 1 by u square du d theta, and using equation number 6 where 1 by r square is u square. Okay, and this will be h, this will cancel out, so we are left with minus h du d theta. This is dr by dt. Differentiating again with respect to t on both sides, we'll get d square r by dt square minus h d by d theta. This will be differentiating with respect to theta because we have to use the composition. Theta will be further differentiated with respect to time, so this will be further equal to minus h d square u by d theta square and d theta by dt, as from equation number 5. This equation number 5 we will be using. It will be h by r square. It will be h by r square, and from equation number 6, minus h d square u by d theta square dot h u square is equal to minus h square u square d square u by d theta square, and this will be equation number 7. Now using equation 7 and 5 in equation number 4, we get, now using equation, now using 5 and 7 in 4, firstly we will write the value of r double dot, which is minus h square u square d square u by d theta square minus r theta dot square. From equation number 5, theta dot is h by r square is equal to minus f. This implies that minus h square u square d square u by d theta square minus h square r cube minus f implies minus h square u square d square u d theta square minus h square u cube minus f, because r is equal to 1 by u. This implies that d square u d theta square, minus is cancelled out throughout, plus u f by h square u square this is the equation of center orbit in polar form. Why it is in polar form? Because it is in r and theta. As u was function reciprocal of r and r was function of theta, therefore u is also function of theta. Therefore this particular equation is called differential equation of center orbit in polar form. And here center of the motion is called pole. Therefore in this particular article we have derived a differential equation of central orbit in polar form. This is very important question from the examination point of view, and very important question. And in the next article we will be deriving the differential equation of center orbit in pedal form, and we will be discussing the aerial velocity, and after that we will come to the question, and that will finish our section. So in this video we have studied the differential equation of center orbit in polar form, which is very important question. If you have any doubt, you could ask me in the comment section. I will be happy to reply your queries, and you are my strength. And please stay connected and keep working hard in your life. You will definitely get success. My wishes are always with you. I am always with you, and I will be posting the videos regularly, 2 or 3 videos in a day, and we will finish the syllabus here, and that is my promise and my faith in the God. Everything will be fine, and stay at home, stay healthy. Thank you very much. Thank you for watching, and if you have liked the video, please like, subscribe and share. Thank you very much. This is Dr. Rajesh.